My dear students, I am going to explain you about coefficient of linear expansion. So before that linear expansion, we should know linear expansion is the change in length or change in breadth or change in height. So in that whenever change is coming, that is the linear expansion. Okay. So in that change it can sometimes it can increase, sometimes it can decrease. It depends on the temperature. Now, coefficient of linear expansion. For coefficient of linear expansion, we use alpha as a symbol for denoting coefficient of linear expansion. Now, this alpha is equals to change in length by original length into change in temperature. Now, change in length is what? Change in length if suppose temperature is increased. So, there will be increase in length. Okay. So, if final length we are supposing L2, then initial length we will suppose L1, then change in length becomes L2 minus N1 because due to change in temperature, due to increase in temperature, length was increased. So L2 is greater than L1. So change in length equals to L2 minus L1, and that can be written as delta L. Delta L denotes change in length. And now change in temperature, initial temperature was less and final temperature was more because I had increased the temperature. So if T2 is the final temperature and T1 is the initial temperature, T2 is greater than T1. So change in temperature, that is equals to delta T equals to T2 minus T1 because T2 is greater than T1. So alpha is equals to, which is coefficient of linear expansion, that is equals to delta L by L1 into delta T. Here delta L denotes change in length and delta T denotes change in temperature. So alpha, that is coefficient of linear expansion, its unit is per Kelvin. So the order of the linear coefficient of linear expansions, order of magnitude is 10 to the power minus 6 to 10 to the power minus 5 per Kelvin. This is the value of alpha, that is coefficient of linear expansion. Thank you. If you like, please share and subscribe.